Okay, well, welcome to Chapter 2, and in Chapter 2, we're going to dedicate the entire chapter to the family of quadratic equations, and we're going to start with transformations. Most of this will be a review, so hopefully you'll feel pretty comfortable with this lesson. Okay, so we're going to start with talking about symmetry, because quadratic equations known as parabolas are symmetrical. In other words, there is a line that cuts it in half. This line is called the axis of symmetry. And symmetry is found in many things. It can be found in insects, it can be found in other geometric objects, letters, even our bodies are symmetrical. The left side matches the right side. And cars, so the left side again matches the right side. And so we can see that symmetry is pretty important in the world. As a matter of fact, when we see something that's not balanced out, we tend to want to fix it. So that axis of symmetry is kind of ingrained into our fabric of thinking. So at any rate, let's take a look at how this relates to the parabola. Before we do that, I want you to take these notes and nail them down into your notebooks, label them 2.1, and fill in your table of contents. And then let's take a look at the first flap. Vertex form is basically a template for the quadratic equation, and it looks like this. Again, we should be familiar with this template from the first chapter. We see that we have an A, H, and K, and these are the three variables that move this parabola, or change it, I should say. H and K move it vertically and horizontally, and A kind of changes it either skinny, wide, or even does a reflection if it's negative. So when the parabola is in this form, we can see the vertex. So we know exactly where that point has traveled to by looking at the vertex. So in this particular set of exercises, we're just going to practice finding the vertex. So looking at these examples, we're going to start with the general template, and that general template, as we know, is this right here, and we're going to see which number maps itself to H and which number maps itself to K, because when we do, that's going to be the vertex. So as you can see, the number 3 and 5 map themselves to those two variables here, and so 3, 5 is the vertex. Again, in the second question, we have a little bit of a change with that plus sign. Notice over here that in the general template it's minus. So in order for it to have been altered to a plus, it had to be a minus -5. And so that's where the mnemonic comes in, where you think X misbehaves, because it's always the opposite of what you think. So the vertex is going to be at -5, and the Y value will be at -3. Remember, this is the one that behaves itself. It does exactly what it's told to do. And notice that this 2 right here played no role in naming the vertex. You don't want to distribute that 2, because you'll be violating order of operations, and we'll talk about that later on in the chapter. Again, in number 3, we're thinking X misbehaves, and we're looking for the Y coordinate or the K value, which is back here. If nothing appears back there, remember the number that represents nothing is 0, and so the vertex is going to be at -7, 0. In like manner, this next equation, we don't see parentheses. Notice there's parentheses here. So the absence of H is manifesting itself in this problem. And so H will be 0. You can see from this little template that if we throw H back in, we get X minus 0, which is nothing more than X, and X quantity squared is X squared. So the vertex is 0, 8. Next, what we're going to do is take a look at the axis of symmetry. Now, the axis of symmetry is that line that divides the parabola into 2 equal parts. It's kind of like the folding line, as we mentioned earlier. It's an equation because lines are in the form of an equation. and that equation is x equals h. This h right here is the same number as the x-coordinate of the vertex. So whatever you get for h in your vertex is going to be also related to the axis of symmetry. The only thing you have to remember to do is to include this x equals. If you fail to put this part into your answer and you just put some number down, then you will not get it right because you're not naming a line. You're naming just a random number out there in space. So let's take a look at this example. H maps itself to the 3. And again, with x you have to think opposite. So that -3, think opposite, it's going to be +3. And so your axis of symmetry is going to be x equals 3. In this next problem, again, that 2 has no role in the situation, and this time neither does the -3, so the answer is x equals -5. And then the next question, x equals 7. And finally, in number 4, remember there's this absence of parentheses in this problem, and so it's x equals 0. Alright, next what we're going to do is take a look at max or minimum values. And I need for you to make this slight change in your notes. It was a typo, so I apologize for that. At any rate, every parabola has a maximum or minimum value. If you think about the U-shaped curve of it, depending on the direction at which it's turned, it will either have a maximum or a minimum. And this is controlled by the value of A. Remember, A controls the direction. So if A is a positive number, the parabola is concave up. And if A is a negative number, then the parabola is concave down. And so this time we are going to be focusing in on this piece right here. So looking at this first example, we see that we don't really have a number that maps itself to A. It's understood to be 1. So A being 1 falls into this category of being a positive number, and so this parabola is concave up. Now again, if you didn't learn this in geometry, this is kind of the mathematical shortcut for therefore. In the second question, the value of A is -2, which means it falls into this category. So it's concave down. In the third question, the 1/4, even though it's a fraction, does fall into this category. It is still positive, so it's going to be concave up. And the last one, again, you're looking at that understood 1. It's a positive number, so it's concave up. Alright, in this next part, this is some notes that you're going to nail down next. I want you to do these problems. So you need to state the vertex, the axis of symmetry, and whether it opens up or down. And we will do the first problem together. So the axis of symmetry, the vertex is going to be HK. X misbehaves. So it's going to be -1. And the Y value is going to be -4. So that's the vertex. The axis of symmetry is just simply x equals h. We already know that h is -1, so it's x equals -1. And finally, we're going to inspect the value of A. A is negative, and so therefore it is going to be going down. So I want you to finish the rest of these problems, and we'll go over them tomorrow in class. Hope this has been helpful, and we'll see you in class.